Think about it. Software is just everywhere now. It's
Yeah.
kind of the invisible engine behind our daily lives, right?
Hmm.
Phones, work systems, the whole world runs on it.
Absolutely. And digging into how it actually gets made, how it evolves, it can offer some, well, pretty surprising insights for anyone who uses a computer, even if you've never coded.
Totally. And a huge chunk of that, especially the really influential stuff today, comes from this idea of open source.
Right. Bob Young, from Red Hat, he put it perfectly. He said Eric Raymond really helped everyone understand why this collaborative way of building software works. And that understanding was key to its, well, massive success.
Exactly. And that's the rabbit hole we're jumping down today. We're looking at this world through a fantastic book, The Cathedral and the Bazaar by Eric S. Raymond.
Mm-hmm. It's a collection of essays, really gets into the mindset, the culture of computer hackers. It's fascinating stuff.
So our mission for this deep dive is to pull out those core insights from Raymond's work.
Yeah.
We want to get a handle on how open source development works, why it's been such a game changer, and what it means for tech, for innovation.
And we'll try to do it without getting totally bogged down in the super technical jargon, make it clear and engaging.
Okay, so hacker culture,
Yeah.
it sounds a bit underground maybe. Where did Raymond say this all started? What kind of environment let it grow?
Well, the beginnings were really back in the day, the era of cheap time sharing on computers. Think 60s, 70s.
Right.
Machines like the DEC PDP-10 were central. And the ARPANET, the internet's granddaddy, was basically a network connecting these. You still hear old-timers talk fondly about systems like Top PS10, Macro 10.
There's like this digital sandbox, a place to just tinker.
Precisely. And what's really interesting is DARPA, who funded ARPANET, they were surprisingly relaxed about people doing unauthorized stuff on the network. Yeah. They seem to get that just letting smart people explore, maybe bend the rules a little, was actually nurturing a whole generation of computer whizzes, like giving kids a really powerful chemistry set.
Ah, okay. And while that was bubbling up on the AR planet, something else important was happening off
Yeah.
the network, right?
Exactly. Around the same time, 1969 actually, Ken Thompson over at Bell Labs created Unix. He'd worked on Multics, another big time-sharing system, but wanted something, simpler, more programmer-friendly.
Mm-hmm.
And then Dennis Ritchie, another Bell Labs hacker, developed the C language specifically for Unix. The point is, Unix and C were built to be elegant, flexible tools. They empowered programmers.
And this is where Richard Stallman enters the scene.
Yeah.
RMS, a huge name.
Absolutely. RMS was a top hacker at MIT's AI lab, and he was fiercely passionate about software freedom. He saw software becoming more proprietary, locked down, and it worried him.
So he started GNU.
Yes, in 1983, he launched the GNU project. The goal: a completely free, open alternative to Unix. It was a rallying cry, really, to preserve that original open spirit of hacking within this growing Unix world.
Okay, so Unix itself started spreading out beyond the lab.
Yep. Early 80s, companies like Sun Microsystems started making Unix workstations, powerful machines running Unix, but more accessible for businesses, universities. Networks of these workstations began to replace those older central time-sharing systems.
Right. And this kind of paves the way for the first free Unix-like systems, which eventually gets us to Linux. How did that happen?
Well, the Free Software Foundation's own kernel, the HERD, it was taking a while. It was proving harder than expected.
Oh.
So into that gap, in 1991, this student in Helsinki, Linus Torvalds, he starts tinkering. He begins developing his own free Unix-like kernel specifically for PCs, the Intel 386 machines that were becoming common. And he used the tools the FSF had already created.
And he called it Linux.
He called it Linux, and it just exploded. It captured the imagination of internet hackers worldwide. People started contributing code, ideas, almost immediately.
What's really striking, though, is how Linux was built. It was totally different from how people thought you had to build complex software, wasn't it?
Completely different. Before Linux, everyone assumed something as complex as an operating system needed, careful planning, a small, dedicated team working closely together, very controlled.
Like building a cathedral.
Exactly Raymond's analogy.
Yeah.
That cathedral model applied to commercial software, but even to big free software projects like the FSF's own work or the early BSD Unix systems.
Uh-huh.
So the success of Linux, built by this sprawling, distributed, part-time army of volunteers over the internet, It was genuinely shocking to many
And
people.
it wasn't happening in a vacuum, right? The timing was crucial with the internet itself exploding.
Perfect storm. Early 90s, you have the rise of internet service providers, the
Mhm.
public starting to get online. Then, boom, the World Wide Web is invented.
Changes everything.
Totally. This internet explosion created the ideal environment for Linux not just to survive, but to absolutely thrive. And this whole new model of open source development really started to gain traction.
Okay, so we have this backdrop. Hacker culture, Unix. Then Linux boosting onto the scene with this radically different development style.
Yeah.
Which brings us right to Raymond's central idea. The Cathedral versus the Bazaar. Can you break that down?
Sure. The core idea is that contrast. The cathedral is that traditional way, meticulously planned, built by a small elite group, very top-down control, like building, well, a cathedral.
Right.
The bazaar, on the other hand, is the Linux model. Open, decentralized, maybe a bit chaotic looking, like a bustling marketplace with lots of different vendors, lots of activity, all contributing in their own way, leading to a coherent whole somehow.
And from watching Linux, this Bazaar, Raymond pulls out a really critical principle. The one about eyeballs.
Yes, that's maybe the most famous line. Given enough eyeballs, all bugs are shallow. Meaning, if you have enough people looking at the code, testing it, poking at it, users, developers, whoever, any flaws, any bugs, are much more likely to get spotted and fixed quickly. It's the power of mass peer review, essentially.
It feels counterintuitive, though. More cooks in the kitchen usually means chaos.
Right.
But here, more eyeballs means more stability.
It does seem that way. And Raymond mentions that quote from Linus Torvalds himself about being lazy.
Oh, yeah. The I'm basically lazy and like to get credit for other people's work line.
Right. But Raymond sees it not as actual laziness, but as a really smart strategy. By making it easy for others to jump in, by welcoming contributions, Linus effectively harnesses the energy of the whole community. He guides it, sure, but the community does a lot of the heavy lifting.
Like conducting a huge volunteer orchestra. Now, this bizarre style, it wasn't totally out of the blue, was it? Raymond mentions an earlier example, even within the FSF.
True. He points to the development of the GNU Emacs Lisp libraries. Even within the FSF's more cathedral-like structure for the core editor, the Lisp extensions and archives showed this more bazaar-like evolution. People shared code, iterated on ideas. It was driven by user contributions, so the seeds were there.
And this links to another key practice in the Linux world, releasing software really early and really often.
Absolutely. The traditional approach was you hold back releases, you polish, you test internally, you release maybe once or twice a year, trying to minimize bugs for the user.
Yeah, the big launch event.
Right. Linux did the opposite. Super frequent releases, sometimes daily, even if they weren't perfect. The idea was get it out there, let the community find the problems, send feedback, and iterate incredibly quickly.
Get those eyeballs on it sooner.
Exactly. Raymond mentions the Ohio State Emacs Lisp archive as an early example of this kind of community-driven code sharing, even if people didn't fully grasp the broader implications back then.
It's like flipping the whole development process on its head. And Raymond connects this to Fred Brooks, the mythical man-month guy, and his point about maintenance costs.
Yes, Brooks observed that maintaining software, especially popular software, often costs way more than the initial development. And paradoxically, the more users you have, the more bugs they find.
Because they use it in weird ways you never thought of.
Precisely. They stress it in diverse ways, hit edge cases. The Bazaar model brilliantly turns this problem into a solution. It treats those users as a massive distributed debugging team.
And letting them see the source code is crucial for that to work, right? It makes their bug reports much better.
Hugely important. When testers can see the code, even if they aren't expert programmers, their reports can be way more specific. It breaks around line 500 in this file when I do X, that kind of detail. It saves the core developers enormous amounts of time trying to reproduce and diagnose the problem. Communication gets way more efficient.
Okay, but what about Brooks's other famous idea, Brooks's Law? Adding people to a late software project makes it later. How does open source, with potentially thousands of contributors, get around that communication nightmare?
That's a great question. Brooks's law is about the exponential increase in communication paths as a team grows. More paths mean more chances for misunderstanding, integration problems.
Right.
Open source seems to mitigate this, Raymond argues, partly through structure. You often have these halo developers working on fairly distinct, separable parts of the project. They don't all need to talk to each other directly all the time.
Ah, so it's more modular.
Kind of. The core team, maybe the original author, a small group, acts as the integration point. They handle merging contributions, coordinating the main direction. The communication burden is concentrated within that smaller core, not spread across everyone equally. It scales better.
So even a vague bug report from one of those many users can still be valuable.
Definitely. A user might say, something feels weird in the network handling since the last update. Even if they can't pinpoint it, that clue might be exactly what a core developer, maybe too deep in the details, needs to connect the dots on several other minor issues and find the root cause. Frequent releases plus many testers equals faster convergence on fixes.
Raymond then talks about his own project, Pop Client, which became FetchMail. He consciously applied these Linux lessons. What did he change?
Well, first he looked at the existing code and thought, this is too complicated. It was very focused on the code logic, not the data it was managing. Drawing on his LISP background, he redesigned it to be more data structure-centric, cleaner, simpler, easier to understand and modify.
And then he deliberately copied the Linux release strategy.
He did. He started releasing very early and very often, sometimes daily, like Linux. And crucially, anyone who contacted him with interest, a bug report, a suggestion, bam, they were added to the beta list. He actively grew his pool of code developers.
Which brings us back to that core idea. Treat your users as co-developers.
That's the central lesson Raymond hammers home. Your beta testers aren't a nuisance. They're your most valuable resource for improvement and debugging. His FetchMail beta list grew to almost 300 people.
Wow.
He even mentions, kind of humorously, that people started asking to be removed from the list because the software just got so reliable they didn't need the daily updates anymore.
That's definitely a sign you're doing something right.
Yeah.
Now, there was a key moment with a user contribution from Harry Hochheiser.
Yes, a pivotal moment. Hochheiser sent in some code for forwarding fetched mail to the standard SMTP port on the user's machine. Raymond looked at it and had this realization. If this feature was done well, it would basically make all the other ways fetch mail delivered mail kind of obsolete.
A much cleaner solution.
Much cleaner, more standard. And this led him to another big insight.
Which was?
That the next best thing to having good ideas yourself is recognizing good ideas from your users. And sometimes, he says, the latter's even better. That SMTP forwarding idea came from a user, and it became the single biggest improvement to FetchMail.
And this user idea actually made Raymond rethink his whole concept for the program.
It did. He originally saw FetchMail as this multi-tool offering lots of different delivery methods, but Hochheiser's idea showed him that SMTP forwarding was just superior. So he made the bold move to make it the default, and eventually he actually removed the other older options.
Even though that might disrupt some existing users.
Yeah, he hesitated but realized it was the right long-term design decision, which leads to another lesson.
Go on.
Often the most striking and innovative solutions come from realizing that your concept of the problem was wrong. He had to change his own mental model of what FetchMail should be.
That takes some humility. And FetchMail kept evolving based on user needs, like adding multi-drop support.
Right. As more people started using it, needs emerged that Roman hadn't initially anticipated. Fetching mail from one central mailbox and distributing it to multiple users multi-drop became a crucial feature for a wider audience.
He also talks about experimenting with the configuration file syntax, adding noise keywords. This sounds odd.
Yeah, it was an interesting experiment. He added optional words like is or to into the configuration commands. The program ignored them. They were just noise, but they made the configuration lines read more like plain English.
Like servermail.example.com proto-POP3 user Bob versus pollmail.example.com proto-POP3 user Bob. Oh, wait, the noise words would be different. More like pollservermail.example.com with proto-POP3 fetch for user Bob.
Something like that, yeah. Making it more readable, less like code. Even though Raymond himself usually prefers terse syntax, he realized that for this kind of simple configuration language, what he calls nowhere near Turing complete, adding this syntactic sugar, could actually be a big win for usability for less technical users.
So the lesson there is about tailoring the language, even if it means adding verbosity.
Exactly. When the language itself is simple, making it friendlier and more English-like can be really helpful. Balance conciseness with clarity for the target audience.
He also briefly touches on security by obscurity regarding storing passwords.
Right. Some users wanted passwords encrypted in the config file. Raymond's point was that this just hides the password behind an encryption method. It doesn't make it fundamentally secure unless the encryption itself is strong and properly managed. Relying on secrecy alone isn't robust security.
Okay, so if someone's listening and thinking, I want to start an open source project like this, what's the absolute first step to build that community?
Raymond says you need to start with a plausible promise. Your initial software doesn't need to be perfect. It can be rough. But it has to work, and it has to show potential. It needs a strong core idea that convinces people, yeah, this could become something really useful if we build on it. Both Linux and FetchMail started with that strong, appealing basic design.
And while a good initial design helps, he suggests another skill might actually be more important for leading a Bazaar-style project.
Yeah, this is interesting. He argues that being able to recognize good design ideas, maybe submitted by others, and integrate them well, is often more critical than being the sole source of original design brilliance yourself.
Like Linus Torvalds with Linux.
Exactly. Or Raymond himself with that SMTP forwarding idea for FetchMail. Being a good curator, a good integrator, is vital. He even admits his own tendency towards maybe too clever designs and how resisting that in FetchMail, keeping it robust and simple, was actually key to its success. Sometimes pragmatic is better than overly original.
Which circles back to Brooks's law again, and how this collaborative model seems to soften its impact.
Right. As we touched on, Brooks's law is real communication gets complex, but Raymond argues the open source process, fostering what Gerald Weinberg called egoless programming, where people are focused on the code, not defending their turf, combined with the sheer brain power of the community. It helps mitigate those communication bottlenecks.
It's not that the law is repealed, but its effects are lessened by the scale and the culture.
Something like that. While coding might be solitary, he says, the great hacks, the big breakthroughs, often come from leveraging the attention and contributions of the wider community.
And he sees parallels here with other complex systems, markets, ecosystems.
He does. He draws analogies to free markets or biological ecosystems where you have lots of individual agents sort of pursuing their own goals, but collectively creating this complex, adaptive, self-correcting order. That emergent order, he suggests, is kind of the underlying magic of the Bazaar model.
Okay, so we've covered the how, the development model, but Raymond digs deeper into the why, the social side, the motivations, this idea of homesteading the new sphere.
Yeah.
What's that about?
Homesteading the new sphere. It's a great phrase. The new sphere is like the realm of thought, of ideas. Homesteading, it means hackers staking a claim in that realm by creating something valuable, like a piece of software, and building a reputation around it within the community.
So claiming intellectual territory.
Yeah, by building things and sharing them. He uses this to explore the motivations behind open source, which seem a bit contradictory sometimes. You have these licenses about sharing freely, but also clear senses of project ownership and reputation seeking.
And he notes that the hacker world isn't uniform in its views, especially about money and business.
Definitely not. You had the Free Software Foundation, RMS, often taking a strong, sometimes explicitly anti-commercial stance, very principled. But there was always another strong current, maybe less vocal initially, rooted in the Unix and early internet culture, that was more pragmatic, more focused on engineering, perfectly happy to interact with business.
And that difference really came to a head around '98 with Netscape.
Big time. Netscape decided to open source its browser, Navigator. Suddenly, the business world was buzzing about free software, but the term free was causing problems. Did it mean free beer or free speech? And some associated it with anti-business sentiment.
So they needed a rebrand.
Exactly. A group got together, including Raymond, and coined the term open source. It was deliberately chosen to sound more business-friendly, focusing on the practical benefits, not just the philosophical ones, and it caught on incredibly fast within the hacker community itself.
Raymond also talks about unspoken rules, taboos within the culture, like not forking projects lightly or messing with commit history. What do these tell us?
These taboos, like the strong disapproval of splitting a project, forking without a really good technical reason, or distributing patches outside the main project, or, crucially, removing someone's name from the history, they reveal the underlying social rules that maintain order. They protect collaboration, respect contributions, and prevent fragmentation.
So how do you become the recognized owner or leader of a project?
Raymond lays out three main ways. 1, you start it, you're the founder. 2, the ownership is passed down to you by the previous maintainer, maybe they mentored you. Or 3, you adopt a project that's been abandoned, an orphaned project, and revive it.
Like stepping in when the original creator disappears.
Right. But in all cases, what's really crucial is legitimacy in the eyes of the community. You need their buy-in, their respect. It's not just about declaring ownership.
And he connects these customs to John Locke's philosophy of property. That seems like a stretch.
It sounds surprising, but the parallels are there. Locke talked about claiming ownership of uncultivated land by mixing your labor with it, homesteading. Raymond sees hackers doing something similar in the new sphere by building software. Concepts like a clear chain of title, who maintained it before, or even adverse possession, taking over an abandoned project, resonate with how ownership works organically in this decentralized community with no central authority.
It's like emergent law. He also talks about social status and how hacker culture works like a gift culture. What does that mean?
So the idea is that humans are driven by a need for social status, but how you gain it differs. In a command hierarchy, it's through power. In an exchange economy, it's often wealth. But in a gift culture, like Raymond argues hackerdom largely is, status comes from giving valuable things away, in this case, code, solutions, ideas, and earning reputation and respect from your peers for those gifts.
So the reward isn't money, primarily. It's prestige, peer repute.
Exactly. That reputation is the main currency. Having a strong reputation attracts attention, makes others want to collaborate with you, helps your future projects get off the ground. It can sometimes translate into job offers or consulting gigs in the regular economy, but the primary driver within the culture is that peer esteem.
But it's funny, he notes many hackers are almost shy about admitting they want that reputation. Why the modesty?
Yeah, there's a strong cultural taboo against blatant egotism or self-promotion. People who seem like they're just trying to build their brand are often looked down upon. So even the big names, the leaders, tend to be self-deprecating. It's a bit of a performance, perhaps, but maintaining that humility is important for keeping status in a culture that values contribution over ego.
And not all contributions are equal, right?
Okay.
An original work is great, but so is liberating existing proprietary stuff.
That's a key point. Creating something totally new gets a lot of respect, obviously, but so does the hard work of, say, reverse engineering a closed file format or network protocol and creating an open source equivalent. Think of the Samba project, letting Linux Unix talk to Windows networks. That's seen as hugely valuable, like freeing up territory from proprietary control.
He even brings in animal behavior territoriality to explain these ownership customs.
It's another interesting analogy. Just like animals mark territory to avoid conflict, these clear ownership norms and project boundaries, like having a dedicated project website, help reduce friction in the hacker world. Who makes decisions? Who gets credit? How do we avoid harmful forks? These customs provide answers, tapping into our sort of primal understanding of territory, even in the abstract realm of ideas.
So the customs aren't just about motivation, they're about practical governance too.
Absolutely. They provide a framework for resolving disputes and coordinating work. The most common model is the benevolent dictator. One person has the final say, like Linus with Linux. But there's usually a strong expectation they'll listen to key contributors, those who own the subsystems. And there are other models too, like the Apache Project's voting committees or Perl's rotating leadership.
How do people learn all these unwritten rules? It's not like there's a hacker rule book.
Mostly by osmosis, Raymond suggests. You watch how established hackers behave, you read the project readmens and mailing lists, you slowly figure out the reputation game. He also talks about hacker culture having mysteries, little tests or hidden knowledge, like needing technical skill even to ask a good question that act as a filter and an acculturation process. You learn by doing and by observing.
It's interesting, too, that psychology research seems to back up the idea that external rewards, like bonuses, can sometimes hurt creativity, which fits the open source model.
Right. Studies suggest that for complex, intrinsically motivating work like programming, things like pay for performance can actually decrease motivation and productivity, whereas a stable salary doesn't seem to demotivate. This aligns well with open source, where the drive often comes from the joy of the work itself, the challenge, and peer recognition, not direct payment per line of code.
Okay, so we got the history, the how, the why. Now, Raymond tackles the economics in the Magic Cauldron, because it does seem a bit magical that all this valuable software is just free. How does he explain the money side?
He starts with that idea of ephemeralization, technology getting cheaper and better as information content increases, and Clark's law about advanced tech seeming like magic. But he argues the economics are understandable if you look past the traditional models.
He really goes after the standard factory model for software, right?
What's wrong with it?
According to him.
The big flaw, he points out, is that the factory model assumes sale price is tied to development cost and use value. But for software, he argues, that's often not true, especially because the majority of the cost over a software's life is in maintenance and support, not initial creation. Yet the traditional pricing, big price up front, maybe small support fees later, doesn't match that reality. It leads to companies underinvesting in support, support starvation, and these winner-take-all markets where even the winner's customers might not get great long-term service.
So what's a better model for the software business?
He argues for a world based more on service contracts, subscriptions, ongoing relationships, like how big enterprise software often works. And his point is that open source forces this shift. When the secret bits of the code are freely available, you can't just make money selling the bits themselves. You have to sell value around the bit support, customization, integration, expertise.
And he lists a whole bunch of ways companies do make money with open source. Can you run through some key ones?
Sure, there's building custom solutions on open source foundations. There's contributing to a big project like Apache and benefiting indirectly. There's the loss leader model, give away the software to sell hardware services, like Netscape tried with Mozilla.
Or hardware makers open sourcing drivers.
Right, widget frosting to make their hardware more attractive. There's give away the recipe, sell the cookbook, give away the software, sell the expertise and support around it. There's selling add-ons or tools for popular open source software, the accessory market.
And companies like Red Hat.
That's the industrial strength open source model, taking open source software and providing robust, enterprise-grade support, packaging, and services. And finally, the faith-based economy, where companies support key projects like Perl or Apache because a healthy ecosystem benefits their own business indirectly.
He also makes a point about trust, especially for critical infrastructure software. Why do customers prefer open source there?
Because it avoids vendor lock-in. If the code is open, you're not totally dependent on one company. You have transparency. You can potentially get support from multiple providers. You have more control over your own systems. It creates a more symmetrical, trusting relationship.
And Raymond identifies certain types of software where open source really shines. What are they?
Generally, it's software with strong network effects, where high failure costs are involved, where it's business-critical infrastructure, or where it relies on standard, well-understood engineering methods. Think operating systems, web servers, core internet protocols, the plumbing of the digital world.
He uses the game Doom as a cool example of how the economics can change over time for a single product.
Yeah, it's a great case study. When Doom first came out, its 3D engine was revolutionary, unique. Keeping it closed source made perfect sense economically. But years later, the technology was less novel, the market had changed. Seduin Software open-sourced the engine. The value had shifted from the secret code to the game's legacy and community.
Open source can also be used strategically as a weapon.
Definitely. He mentions cost sharing, like Apache being a collaborative way for companies to build a strong web server to compete with Microsoft's ISA without each company bearing the full cost. Or preventing a chokehold Netscape open sourcing Mozilla was partly a desperate attempt to stop Microsoft from completely controlling web standards through Internet Explorer.
Or just breaking a monopoly.
Right, killing an extortion racket. If you're stuck with a single proprietary vendor charging high prices, an open source alternative offers an escape route. And for customers, again, it means choice, avoiding lock-in.
What about the fear of Linux fragmenting into incompatible versions, like happened with proprietary Unix back in the day?
Raymond addresses that. He argues that while there are different Linux distributions, like Red Hat, Debian, Ubuntu, the core kernel and the development process are much more unified and collaborative than the old Unix wars. The community has strong incentives to maintain compatibility because the shared code base is the foundation of everything. It's structurally less prone to harmful fragmentation.
And this phenomenon of star hiring, companies hiring key open source developers.
Yeah, companies like O'Reilly, Red Hat, VA Linux Systems back then hired well-known hackers. Partly, yes, it was strategic, hoping to benefit from their expertise and influence, but Raymond suggests it was also partly driven by a genuine desire to support the community and ensure key projects continued. These companies often had, and have, very close ties to the developer community, more like service firms than traditional product companies.
And then we saw venture capital and IPOs enter the scene. A big shift.
Huge. It showed mainstream financial markets recognizing the economic power and potential of open source. Companies built around open source started getting serious investment, going public. It was clear validation that this wasn't just a hobbyist movement.
He even mentions early attempts at creating markets to fund specific open source tasks.
Right. Things like Source Exchange. Early experiments in trying to directly connect funding to specific feature development or bug fixing in open source projects. The models have evolved since then, but the idea was emerging.
So looking ahead, what were Raymond's predictions for software markets? Where would open source dominate and where would closed source remain strong?
He predicted infrastructure, the plumbing, the operating systems, the core protocols would largely become open source. Applications, especially niche ones without strong network effects, would likely remain the stronghold of closed-source proprietary software, and middleware would be mixed, depending on factors like how critical it is and the cost of failure.
And the long-term destiny for most software.
Is either to die off or eventually become part of that open infrastructure, which in turn constantly creates new opportunities for innovation at the application layer on top.
He also tackles security through obscurity again, especially for hardware drivers.
Yeah, he makes a strong case that hiding driver code for security is futile. Reverse engineering is always possible. He argues vendors should open source drivers. Why? It lets them focus on better hardware, they get faster bug fixes from the community, it future-proofs the hardware against the OS vendor changing things, and ultimately, better supported hardware sells more units.
Okay, so wrapping up, Raymond reflects on how surprising Linux's success initially was, and how that led to him writing The Cathedral and the Bazaar.
Exactly. He was genuinely baffled at first. How could this seemingly chaotic, distributed effort produce software that was so good, oft better than commercially developed alternatives? That puzzle drove him to observe, analyze, and try to articulate the principles he saw working. He realized the community had evolved this incredibly effective method organically without a formal theory.
And when he presented the essay, the reaction was huge.
Massive. Especially at Tim O'Reilly's Perl conference. It spread like wildfire online. It gave people a language, a framework to understand what they were already doing or seeing. That standing ovation wasn't just for him. It felt like a recognition of the power of the whole hacker culture finding its voice.
And this directly fueled the push to coin the term open source.
Yes. As we discussed, the Netscape announcement created buzz, but the term free software had baggage. Free was ambiguous. Cost versus liberty, and it carried associations for some with being anti-business. Open source was crafted specifically as a pragmatic, business-friendly alternative at that meeting in February '98.
A strategic marketing move,
Yes,
basically.
absolutely. The campaign focused on practical benefits, reliability, cost, features. Target the bosses, the CTOs. Use Linux as the poster child. Teach hackers how to talk to the business world. It was a conscious effort to rebrand and broaden the appeal.
Though Raymond himself apparently had some qualms about becoming the public face of it all.
He did. He mentions the personal costs, loss of privacy, less time for actual hacking, the risk of being misunderstood. It wasn't a role he initially sought out.
He even talks about using optimal provocation in his talks. Sounds tricky.
Yeah, finding that balance. Saying things that were unconventional enough to make people think, to be memorable, but doing it in a way that still seemed honest and direct, not just deliberately inflammatory. Cutting through the noise.
The campaign had phases, right? First, convincing the hackers themselves.
Yes. Step one was getting the existing community on board with the new label and the pragmatic messaging. Surprisingly, that went pretty smoothly. Many felt it was a more inclusive and effective way to communicate. The Free Software Summit helped solidify that consensus.
And then turning outwards to businesses after Netscape opened the door.
Exactly. Recruiting early adopters, showing successes beyond just Linux. There were bumps, like Mozilla's initial slow progress, but then key wins, like Corel's Linux device, and especially Oracle and Informix announcing Linux support that was huge. It signaled to other big software vendors that Linux was a serious platform.
And ironically, Microsoft's own internal Halloween documents helped the cause.
Hugely, yes. When those leaked memos surfaced, showing Microsoft saw Linux as a serious threat and acknowledging the strengths of the open source model, well, it was massive validation from the biggest player in the industry. It boosted credibility immensely, even got Wall Street interested.
He shared some predictions back then, too. Looking back now, they seem pretty spot on.
Yeah, things like Samba on Linux replacing Windows NT file servers, proprietary Unix fading, Linux growing strong in servers and ISPs. A lot of that played out much as he anticipated.
In the books afterward, he briefly muses on whether the open source model could apply beyond software. What's his take?
He acknowledges the question comes up naturally, but he's cautious. He argues that software has this unique, intense need for debugging and maintenance by a community, making the peer review model especially powerful. That doesn't necessarily translate directly to things like music or books in the same way.
So what does he see as the main point, the core achievement of the movement?
Raising the bar. Changing expectations for software quality and reliability. Shifting the industry's standard practices away from purely proprietary models towards embracing openness. While acknowledging the philosophical underpinnings, he stresses that improving software was the central pragmatic goal.
The book ends with a really useful section, What is a hacker? Trying to define the culture and the mindset. What are the key traits?
He points to the jargon file for deep definitions, but stresses it's about technical skill, loving to solve problems, and being part of that historical community that built the internet, Unix, the web. He argues cultivating these attitudes isn't just about fitting in, it helps you learn and stay motivated in any creative field.
And what are those core attitudes he lists?
Things like, the world is full of fascinating problems. No problem should need solving twice. Boredom is evil. Freedom is good. And crucially, attitude is no substitute for competence. You have to have the skills.
What skills does he say are fundamental?
Learning to program is key. He mentions C, Perl, LISP specifically back then, getting and using an open source Unix like Linux, being part of the internet, reading, writing, participating, contributing back to open source projects, and serving the culture itself.
How can people contribute, practically?
Report bugs well, help newbies, package software for easier installation, help with documentation, take on maintenance tasks for existing projects, serve the culture, write FAQs, maintain archives but without being egotistical about it.
And he has those fun points for style things that resonate with the hacker mindset.
Yeah, like writing well, reading sci-fi, maybe studying Zen or martial arts, having a good ear for music, appreciating wordplay and puns. And interestingly, using your real name, online hackers tend to value taking responsibility for their work. He also gives pointers to other key readings.
So, stepping back from this whole deep dive into the Cathedral and the Bazaar, what's the big picture takeaway on open source's impact?
I mean, it's fundamentally changed how software is made, right? It proved that this open, collaborative, peer-reviewed approach could produce incredibly high-quality, reliable systems, challenging the dominance of closed, proprietary methods. It unleashed a huge wave of innovation.
And for listeners, maybe not in software, what's a principle from the Bazaar they could maybe apply elsewhere?
I think that core idea of open collaboration, of genuinely treating your users or your audience or your collaborators as partners, embracing diverse contributions, understanding that collective intelligence and scrutiny often lead to better, more robust results, that's applicable in so many fields beyond code.
So yeah, understanding the Bazaar isn't just tech history. It's got these broader lessons about how we can solve problems together, how innovation happens in this connected world. It definitely makes you think about the future of collaboration, that sort of magic of distributed intelligence that open source tapped into.